Everyone, welcome back. Today I chose a one deprecated API in Android, and I have a feeling no one is using now in the production, and its name is Async Task. So I still remember when I used first time and I'm amazed. If I'm not wrong, it's 2012 or 13, and how when I use that, I really feel wow, that is an amazing API because it's helping me for the background work, and it's at that time it's simple for me. So yeah, we are going to start to code review of this API. And so this is the async task class. It's deprecated, no one is using, I think so, from last 5 6 years. This is like people will moved or migrated to RX, and then after that things start working and then the core routine comes. But I think it's good to understand how they implement it, and we can learn something new. So if you never saw this, it means you started your Android development maybe in 2016 or 17. So it's a pretty simple API. You need to implement in this way. So any task, you can create a new class and extends with this, and there are some methods which you need to override. So do in background means this code will always execute on a background thread. On progress update, I think it's a UI thread. On post execute, I'm 100% sure it's a UI thread, and there is one more method on pre execute, that is also a UI thread method. So only you need to implement, and then it will work for you. And with the passage of time, we start facing a lot of issues with this memory leaks once the fragment configuration changes. There are many issues, and then later they decided to deprecate this API. So we can read little bit. Okay, yeah, there are 4 steps it's mentioned. So on pre-execute, invoked on the UI thread, then do in background, and then by calling the publish progress API progress update will call, yes, this is a UI thread, and then again there is a UI thread. And canceling is a pretty hard topic in case of a async task. In coroutines it's pretty easy, structural canceling, so you do once and everything is cancelled. In this case, maybe we will see if the code is still there, how it works, but it's like a confused name. And sometimes I found in a code, some developers are using, okay, do cancel, but they are not implementing under the hood the code which is going to make this cancel. Like it's not easy at that time. So we will see. Then they have this, yeah, I remember the threading rules. So basically they change with the OS, like new framework APIs. Once the new OS is there, so first it's a serialized, then after that they did, I think so, parallel, and then they again moved to the serialized, something around that. Sorry, I did not remember properly, but I remember there is some issue, and then you need to understand, okay, which OS API is working. So the async class must be loaded on the UI thread. This is done automatically as of build jellybean. The task instance must be created on the UI. Execute must be invoked on the UI thread. Do not call on pre-execute, on post-execute. Do in background manually. Okay. So the task can be executed only once. So by writing this, you can understand the problems, because that, so so basically Android, how we can say, this API is don't have a constraint, so it 100% dependent on a developer. But now, uh, how they are implementing, they are putting constraints where they want, and you don't have the access. So it's currently, it look like the public API, but they are expecting you should not use. And then memory observability, effects of on pre-execute, I think this one remaining we will discuss later. Oh yes, so they have this order of execution. When first introduced, async tasks were executed serially on a single background thread, starting with build donut. This was changed to a pool of threads, allowing multiple tasks to operate in parallel. Then again start with honeycomb. Tasks are executed on a single thread to avoid common application errors caused by parallel execution. So first they introduce here, then after that they found there are a lot of bugs are coming by the developer community, and then they move again back. Then after that they also give the option, I think so, if I'm not, yeah, if you truly want parallel execution, you can invoke execute on executor, and by giving this information. And now they're saying, okay, deprecated, use Kotlin concurrency utilities. Okay, so now going inside of a code, async task, it's a generic which, So it's a generic, it take three parameters, we will say params. It's like for example, as a developer, what I want to send, mostly it's a URL. Then progress is mostly integer or float, like they will push you to back like, hey, there is an update. And result is a return type from the background, which we will get in a on post. Or what we can do, maybe I can try to, yeah, I know we are interested in the open source code, but I think it's good if we can see this code in case of an implementation. So I'm saying, okay, I will send you URL, return me progress as an integer, and the later result will be list of something, maybe string. So that is my required task. Then this is the do in background. Okay, invocation. Then here any operation which will the code which execute here, it's always on a background thread. And I want to send empty list, for example. Then what else, there are some methods, override methods, and we can do all these. So on pre-execute, just like we discussed, it will call on post execute, on progress update, on cancelled. So this is the whole how it works. So result, it's a UI, so you can do work in a UI. In progress update, you can do the dialog if you have a like showing the progress bar. In case of a cancel, if it's cancel or not. So this is the implementation. Now moving back, so how they implemented, okay, they have some static fields, core pool size 1, maximum pool size 20, backup pool size 5, keep alive seconds 3. Then what they did, okay, they implemented a thread factory internally. Okay, so now they are using atomic integer. So atomic integer means this object will take care of the concurrency. Anywhere you read the atomic, it means it's safe from the multiple threads access. Maybe we can spend 2 or 3 minutes. So basically how it's implemented, it's internally under the hood, it's an integer, a simple integer, hopefully, yes, like this. And they are using volatile somewhere because they want to access the direct memory, not the. So on different architectures, I'm not very good with these under the hood how things work, but what I remember, and when I use this, I have some kind of a perspective which helped me out. So basically under the hood, if you have two processors and there are two threads working on both processors, then they are accessing this value. So in case if it's not volatile, there is some cache mechanism at a hardware level architecture. So if you want to remove that and you want, okay, no, every thread should get the original memory address, there should not be any copy between the caches, then you will put the volatile. And then remaining how they are managing, you can read all of these APIs. It's pretty amazing, but it make your life very easy. So then after that, inside they create a new thread by putting, okay, get and increment. Now next is ThreadPoolExecuter. So this is an API from the Java and still valid. You can use, instead it's used in many other libraries behind the scene. So I think we can skip this one, otherwise video will take long. Then LinkedBlockingQueue, again this is still valid, you can use anywhere multiple times. Some libraries under the hood they are using this, is it's you can read more about this. I am skipping again so we can focus only on async task. But for now we have a ThreadPoolExecuter, we have a LinkedBlockingQueue. Then what they have, rejected execution handler, run on serial policy. Okay, and once they initialize, what they are doing, rejected execution exceed thread pool size, synchronization, then backup if it's okay. They are initializing here, create a queue, then as backup executor thread pool. So they are making the new thread pool which have these values which we already saw. Then they are giving this information. So basically until at this point what we saw, that all those these values are used in the initialization of this executor, ThreadPoolExecuter. And then after that they are saying, okay, backup executor dot execute, what is r is a runnable. Okay, Then they have this thread pool executor again. This is an executor API, I remember. Yep. It's kind of a runnable. It has not runnable like the internal is, it's only have a one interface a functional interface, and it will run the command which is runnable. And coming back to the async task static, now they are initializing thread pool executor again. In this case they have all this. Now there is a one more new data structure. Wow, that is amazing. So until now we found three new things. One is a thread pool executor, then blocking queue, then synchronous queue. And you can go inside and read what is this, what is the difference between this and the other queue. Then they are setting also rejected execution handler, uh, and once this one is okay, this one is like set internally, then they are initializing this static method with this. Okay, then next is serial executor. So this one is a thread pool executor, this is a serial executor. And how they are initializing, so serial executor is the internal class, this implements execute. Now they are using array dq, one more data structure. So that is nice. So in this case it will run one at a time. So if you are, if I'm not wrong, if you run async task as a serialized, then all the tasks will be saved in this array queue, and then it will take one at a time, and then it will run. So it will execute in the form of a serialized. Then coming back to the initialization, message post result, message post progress, then serial executor, default executor, internal handler. What is this internal handler? Okay, again they are initializing a handler, and should be looper also. So they have a looper, and then they are sending messages by using this. So at this point, if you know a little bit about the looper or a handler, looper and handler, this code will be understandable. It's easy. Then coming back to this, where we are at this point, serial executor is initialized, we saw. Then there are statuses. Okay, pending, running, finished, indicate that the task has not been executed yet. Okay, what is task? We will see what is task. Then internally they are asking get main handler. So main handler you can ask easily looper dot get main looper. Okay, so this handler is initialized by the main looper. So main looper means, if I'm not wrong, this should be the main thread looper. So once the our zygote is there, the process started, there is a looper which is a main looper, and then this handler is also initialized with that looper. Then we have also handler. Nice. So this give us as handler. If it's null, it initialized. In this case it directly give us the handler. If not initialized, it may be null. So I don't know, maybe due to the performance, I don't know what is the reason but for these two methods. So I think if every time I call this, maybe they are playing with this m handler. We will see if we are, they are also updating somewhere else. Then default executor. Then now we are on a constructor. So this is the constructor must be invoked on the UI thread. Then this is the constructor, one more constructor with a handler. Then looper callback. Then what is this worker? I did not saw this API. So okay, we missed this part. So worker runnable, and internally it's param. So what is this API? Okay, so it's an internal class which has param and result, and it's saving these parameters and callable. Okay, so it's an internal class. Then future task, this API, I think most of the developers are aware of this. So you can use this API for the async coding. uh, I'm not going to jump into this, we can go back. But under the hood for the async task, they are using now future task. We found they have also the thread and looper, the main looper. Then we will see how they are working. Then we found serial executor is different, that is using under the array queue. Then they have a parallel thread executor. Then what else? we are here. What they are doing, they are initializing this new work runnable, then m task invoke dot set true, then thread policy background do in background. So this is the, I think so, the o method which we overloaded, do in background, then result, once result will be back, finally that post result. So this is a main, I think so, this is the main code which they are initializing, and now in future most probably they will invoke this. So now here they created a new feature in a constructor, m worker is given here, and then it's called post result if not invoked get, then post result if not invoked. Post result if not invoked is saying okay task, what is m task, okay this is the again atomic boolean, and then this post result is the, I think so, this one. So no, this one is a post execute, I sorry, post result internally should call. So once the post result is called, the result type is which I am sending here as a list of string. So in this case this will be a list of string. Then they are saying okay get handler, get handler which will give us a m handler, which is as per our knowledge we saw it's a main looper, obtain message post result, and then new async task result. Okay, internally they have one more class we will see later, and then send to target and then return result, get status, then do in background. This one is the one which we need to implement, we saw here, do in background. Then pre-execute is a protected method, protected method on progress is a protected method. Then on cancelled, internally calling on cancelled, which is again the protected. So it's on you, you need to call this. So sometimes people are not overriding this, but they are trying to call is cancelled, and we will see what is cancelled. So here they are saying is cancelled is again it's atomic boolean, and it's returning some value. Who is updating this? So someone needs to call this if you want to cancel. So if you are not calling this method like cancel, and you are trying to do is cancelled or on cancelled, it will never do a cancellation. If don't understand, please ignore, it's okay, because this API is now deprecated. Only enjoy the this API. Then they are also trying, they are calling future dot cancel, maybe interrupted if it's true. Then okay, so once cancel is called, in that case this is 100% is cancelled. It means when someone called is cancelled, it will always return true, but this one is depend upon this value, true or false. Then result get future dot get, and then get future dot get timeout unit. Then this is async task execute on executor. So this is the default executor which is a serial. Then they have this method execute on executor if it's pending. So now here they are using status case running, illegal static session cannot execute task, the task are running. So yeah, I remember if you initialize once the task, you are only allowed to use that one. If you call twice execute then execute, it throw this exception. And finish cannot execute task, the task has already been executed. Yes, so this one is done. Then here they are changing the status. Then on pre-execute call, then after that params are updated which we are sending, then exec.execute and then future and return this. There should be one more, yes, this execute. So that this one is directly calling default executor, and this one is the method which will call our enable. Publish progress, how they are, so basically publish progress is a UI, that's why they are using main looper, because it's a UI main thread. So get handler dot obtain message, message post progress, and then send this, send to target, which under which after the execution it will come here. So they are using message mechanism, looper and handlers to send the messages. Then in case once it's finished, it will do okay is cancelled on cancel result on post execute. So it depends. If user already called cancel true, then in that case on cancel will be called. Otherwise on post execute will be called and status will be changed to finish. Internal handler, we already saw how they are managing, how they are sending this information. And then work runnable we already saw. So eight async task result, it's again one internal API. What this will do, it's only the, we can say kind of a data class who is responsible to save the data. So this is a async task. It's pretty nice, and we found three or four data structures which are used under the hood. First is a um first is the atomic variable. We found atomic variables. Then we found the link blocking queue. Then we found the synchronized queue. Then we found the thread pool executor. Then we found, okay, it's using future task API under the hood. And for the messaging passing between the client code is used the main looper. And and the worker runnable is also under the hood. It's kind of a data class where they are saving this information which is given by the client. Hopefully you guys enjoyed this video. See you in the next. Bye.